This recording will include section 11.5 binomial theorem. So we learned that a square of a binomial sum, for example, a plus b squared, will equal, we learned this in college algebra class or algebra class, a squared plus 2ab plus b squared. But how can we calculate if the exponent is not squared, but to the third, fourth, or fifth power? We can use the binomial theorem to find the nth power of a binomial sum or difference by using the binomial theorem, where the notation n, 0, and 1, and 2 will represent the following. n0 and nn will equal 1. n1 will equal n over n minus 1 equals n. And the general rule, this represents a code combination, which n factorial over k factorial times n minus k factorial can be calculated fairly easily by hand for some values of n and k, or we can also learn how to find it in the calculator. So for example, 5 over 2 represents 5 factorial. 5 would be your n, 2 would be your k. 5 factorial over 2 factorial times 5 minus 2, which is 3 factorial, which will equal, if I really expand it, 5 factorial is, 5 factorial is 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. 3 factorial is 3 times 2 times 1. And then we can start simplifying. 2 goes into 4 2 times. 2 goes into 4 2 times. 4 times 2. 5 times 2 is 10. For more cumbersome calculation of n over k, the calculator can be used. It can be found using the math button and navigation to the prob menu, selecting NCR. Depending on the model of the calculator, you might need to enter the value of n prior to pressing the math key. So find each of the following by hand, then check using calculator. So I will explain how to find it with hand, and then we will use our calculator. So by definition, this will mean 10 factorial over 3 factorial, and then 10 minus 3 factorial, which will be 10 factorial over 3 factorial times 7 factorial. And if we would write a list, we know that 10 factorial means 10 times 9 times 8, 7, 6, 5, 4, 3, 2, 1. 3 factorial is 3, 2, 1. 7 factorial is 7, 6, 5, 4, 3, 2, 1. So this will automatically cancel out, and we can have 2 goes into 8 4 times, 3 goes into 9 3 times. So multiplying 10 times 3 times 4 is 120. If you have a TI-84 or TI-83 calculator, this is how you can use your calculator to find this value. If you have a different calculator, you can always Google and try to find that YouTube tutorial that will show you how to find. So TI-84 3 or 84 calculator. You're gonna turn on your calculator. You're gonna type in the number 10 because we are doing 10 over 3. Then you will find the math button on your calculator. And with the arrow, you will move the arrow to PRB, probability, PRB, and then move the arrow down to the third option, which has a combination C and R. Then you will hit enter, and you will hit the number 3, and you will hit enter again. So your answer should be 120 using the calculator. So I will highlight how to find this on the calculator. We will use the calculator often, but we will also need to understand how to find this combination by hand. So let's look at the second example. Try to make some room. 10 over 13. So this will be 15 factorial over 13 factorial times 15 minus 13. So that will be 2 factorial. So we know 15 factorial includes all the way 13 down to 1. So only the 15 and the 14 will remain because this 13 factorial will cancel out with the other 13 numbers multiplying 1 through 13. 2 factorial is just 2. So the final answer will be 105. And with the same technique, you can use plug in 15, then the math button, move down to the probability. Then you're going to move down to number 3 where you see the NCR symbol. You're going to hit enter. You put the number 13 in, and you also going to hit, and after you're going to hit enter, so you will get 105 if you're using your calculator also. The patterns in the expansion of a plus b to the n power will follow. The expansion has n plus 1 terms. So if, let's say, you have a plus b to the third power, then it will have 4 terms. If you have a plus b to the fourth power, you will have 5 terms. The power of a decreasing by 1 in each term from left to right. The power of b increases by 1 each term from left to right. The sum of the powers in each term adds up to n. The coefficients are symmetric about the middle terms. The coefficient of the r term will be n over the r minus 1 combination. The power of b in the r term is the term r minus 1. The coefficient of the terms can also be found by using the Pascal triangle. So some students like to explore using the Pascal triangle. This is if we have to the first power, or this would be to the, this would be to the 0 power. This would be to the first power and the second power and so forth. So let's practice a bit just to understand what we are using. What are we remembering is the n over 0 factorial, or a combination is 1. And then the n over n is also 1. So let's keep that in mind. So when I do the binomial, so if I want to use the binomial rule, just following the rule, we have 2 over the 0 and then we have x and 5. So we have x squared and 5 to the 0 power plus 2 over the 1 x to the first power times 5 to the first power, plus we go 2 over 2, and we have x to the 0 power and 5 to the second power. That is applying the binomial theorem. 2 over the 0 by definition is 1, so we would have 1. This will be a 2, and this will be a 1. Anything to the 0 power is 1, so we get the 1 times x squared, 2 times 5, which is 10x, and this is 1, x to the 0 power is 1, 5 squared is 25. Let's look at our second example. Again, this is the relatively easy one. To the second power, so 2 over the 0, then we have 2x to the first power and 3y to the 0 power, or I'm sorry, to the second power. Because if this is a negative, you're gonna have alternating signs, so minus, we're gonna have 2 over 1, 2x to the first power, 3y to the first power, plus 2 over 2, 2x to the 0 power, and 3y to the second power. So again, we're going to have the two, this is a 1, this is a 1. So remember, you have to square this, 4x squared minus, this is a 2, and then we have 2 times 2 is 4 times 3, 12xy. And then we will have, this is a 1, this is a 1, so 9y squared. So it gets a little more time consuming when we have to the third or the fourth power. So we will have a few examples just to practice. So we have to the third power, that means we're going to have 4 terms. So we have 3 over 0, b squared to the third power and 3 to the 0 power minus 3 over 1, b, sorry, this is cube, so this should be to the third power. B to the second power, and then 3 to the first power, plus, try to slow down, 3 over 2, b to the first power, 3 to the second power, minus 3 over 3, b to the 0, and 3 to the third. So as we see, one of the terms exponent, b to the third, b to the second, b to the first, b to the 0, decreasing. The other term, which is a 3, started 3 to the 0, 3 to the first, 3 to the second, 3 to the third, increasing. So after we simplified, and this was a b to the second original, right? This is a b to the second. So let's make sure. B to the second to the third, b to the second to the second. So the original was b to the second, and then we have b to the second to the first, and then b to the second to the 0. So we have to be careful what was our first term and what was our second term. So we will have b to the second to the third is b to the 6. Remember, this is a 1 and this is a 1, minus, we have 3 to the 1. So this will be 3 factorial over 1 factorial times 2 factorial. So this will end up being 3. Or this is easy to do by hand. If something bigger number you might want to do with your calculator. So this will be 3 times b to the second, down to the second, which is b to the fourth, times another 3. The 3 over 2, right? This will be, again, another 3. So this will be matching. 3 factorial over 2 factorial times 1 factorial, which will be 3 again. B to the second times 9. And then we know this is 1, we know this is 1, so 3 to the third, which is 27. So b to the 6 times, b to the 6 times 9b to the fourth, 27 b to the second, and then plus minus 27. If it's a minus between the terms, then you have alternating a positive term, negative, positive, negative. So we have to be careful when there's a minus between the binomial. So we're moving on to B, because this is to the fourth power, we will have 5 terms now. So I'm going to try to write it a little bit more spread out. So we're going to have 1, 2, 3, 4, 5 terms. So the first term will be, well, actually, I might need more room, so I'll just do 1 term at a time. So we will have 4, 0, x to the fourth, and then we have 2y to the 0. The second, might need more. 4 over 1, x to the third, 2y to the first, 4 over 2, x to the 2, 2y to the 2, 4 over 3, x to the 1, 2y to the third, and 4 over 4, x to the 0, 2y to the fourth. So we can list all the terms, and now you know how to set up 4 over 0. We know that's a 1. You know 4 over 4 is a 1. You know how to calculate 4 over 1, 4 over 2, 4 over 3, whether you want to use your calculator or you would like to use manually. You should be able to do it. So for the first term, we will get 0. Anything to the 0 power is 1. So we're going to have x to the fourth. Our second term will be 4 times x cubed times 2y. Then the third term will be 6 times x squared. And then 4y squared. The next term will be 4 times x, 8y cubed. The last is 16 times y to the fourth. So putting it together, we will have x to the fourth. Remember, it was a minus. So I'm going to continue here. So we're going to alternate the signs. Minus 8x cubed and a y. So we going from here, this one 4 times 2, that's how I got the 8, plus we will have 24x squared y squared. So I'm over here, 6 times 4. 4 times 8 is 32 xy cubed, and plus 16y squared, or y to the fourth. So that will be our final answer. And here's another one with 4. So we have 4 over 0, 2r to the fourth, 3t squared to the 0, 4 over 1, 2r to the third, 3t squared to the first, 4 over 2, 2r to the second, 3t squared to the second, 4 over 3, 2r to the first, 3t squared to the third, and 4 over 4, 2r to the 0, and 3t squared to the fourth power. Again, we can do it step by step. So this term will be 16r to the fourth. Again, we'll do the same steps. End up being 96r cubed t squared. Following will be 216 r squared t fourth, 216 r t to the sixth, and then 81 t to the eighth. So you can add, this is a plus in between them, so we would be adding all the terms as our final answer. So let's go ahead and practice just a little bit more. Write the first 3 terms. We only gonna write a few terms. We're not gonna do a whole lot, just to practice using your calculator if you need to. First 3 terms, so we have 10 over 0, a to the 10, b to the 0, plus 10 over 1, a 9, b 1, and then 10 over 2, a 8, b 2. Further equals, this is 1, so we will have a 10. 10 over 1 is 10, so we have 10 a9b, and then 10 over 2 is 45, a8b2. Again, we're doing the first 3 terms only, so 12 over 0, we have 2x to the 12th power y to the 0 minus, again we are rotating, alternating, 2x to the 11, y to the first, 12 over 2, 2x to the 10, and then y squared. This is when you can use your calculator. So this is a 1. This is a 1. Then you use your calculator. 2 to the 12th power, 4096. X to the 12. Then we have 12 over 1 is 12. Again, you make 2 to the 11th power, and we will get a big number, 24,576. X11y. And 12 over 2 is 66. And then you have to take 2 to the 10th power. So again, we got a big number, 67,584. X10, Y2. And lastly, 9 over 0, 3m squared to the 9, 2w cubed to the 0 minus 9 over 1, 3m squared to the 8, 2w cubed to the first, and then plus 9 over 2, 3m squared to the 7, 2w3 to the second. Again, you can use your calculator. We're getting really big numbers for coefficient. 19683, m to the 18, 118 or 1,098, M16 W3, and then plus 31,4,928, M14 W to the 6. So again, just have to do it slowly, step by step. Find the term containing x to the 7 in the expansion of x plus 2a to the 18. Find the term containing x to the 7. So if we look back, we know that the exponents, so our term, we have an x, our term, we have a 2a. The exponents of the term has to add up to 18. So for example, if I have x to the second, 2a will be to the 16th power. So when x to the 7, the 2a term will have 18 minus 7 to the 11th power. So what we always start, right? A term will be 18 and then a number here. If we look at the patterns, the number under the number is the exponent of the second term. So we know if x has to be to the 7th power, 2a will have to be to the 11th power. So we would have an 11 under here. And then we would have x to the 7 and then the 2a to the 11th power. So this is the term that would have the x to the 7 in there. We will get 31,824 x to the 7, and then 2 to the 11th power is 2,048, a to the 11, and of course, multiplying these two numbers, it's really big. 65,175,552, x to the 7, a to the 11. That would be your final answer for this problem number 4. Find the coefficient. Again, the coefficient is the number part in the term, right? So let's find a coefficient. This is a similar concept. We have 2x as our first term and then 3y as our second term. We want to have a 7 here, and our second term should have the 8. So when I set this term, again, the numbers have to add up to 15, and the coefficient of the second term goes in the bottom. So we have 2x to the 7th and 3y to the, it's negative to the 5th, to the 8th. So you can use your calculator to find the 15 over 8, 6435. 2 to the 7th is 128. And then negative 3 to the 8 is 6,561, y to the 8. So multiplying these numbers gonna be the coefficient, which is 404, 104, 408, a really, really big, long number. And this is the end of section 11.5.